Welcome grade 9s to Miss Nicholson's extra tutorials. In this video we're going to find the rule for a linear graph. That requires to actually work with a set of data, so x and y values. It also requires to find the gradient and also the y-intercept and plotting the graph. So let's say you were given a table of values. So we've got x at 0, 1, 2, 3, 4, 5. And our y is 4, 7, 10, 13, 16, and 19. So if you had a set of data like so, where you've got the x and y points, what can we do? We can plot this on a graph. What plotting means, plotting on a graph, is putting these points, these coordinates, on a graph. So let's draw our graph, which is a Cartesian plane. This is known as the Cartesian plane. The vertical axis is known as the y. Our horizontal is known as our x. So you must label those when drawing your graph. What is also important is to have the correct scale between each point. And it's also important to have the same space between each point to make this graph as accurate as possible. On my x, since we have quite high numbers, I'm going to go up in 5s. And this is 20. Okay, so what we need to do is our first point. What do we have? 0, 4. This way of writing coordinates is known as ordered pairs. You should always put your x value first and then your y value. So what we need to do is x equals 0. Well, we know that means that our x value is at the origin. Where is our y though? Our y value is at 4, so we're going to have a point right here. Doesn't want to draw so well. There we go. Now, let's look at our next point. Well, we know x equals 1. So we're looking at this value here. So we can actually draw an imaginary line with our ruler. And we know that it has to sit somewhere along here. What does our y equal when x equals 1? It equals 7. So we need to go across on our y-axis and see where 7 is. So we're going to say 7's about here. So that point is going to hit here. And then we can rub out our invisible line. Now we go to our next point, which is x equals 2. So we draw our invisible line. If you've got a ruler, you just put it like so against the 2 and draw your invisible line. So we know it has to hit somewhere on this line. Let's look at our y-axis. When x equals 2, y we know equals 10. So we draw a little invisible line there and we know that it equals there. So now we can rub out this invisible line. And we follow like so. So when x equals 3, y equals 13. So it should be here. 4 is 16, so just a little bit above. And 5 is 19. And if we've drawn it correctly, we can then rule a line straight through those points, and we can recognize it's a linear relationship. This is how we plot a graph. A lot more straight than I have in this diagram, but this is how you would plot a graph. Once we've plotted the graph, how would we find the rule that represents this line? Well, we know that any linear equation is in the general form of y equals mx plus c. What does our m represent? Our m represents our gradient. And there's a way we can actually work out the gradient. Our c also represents something in this equation. It represents the y-intercept. What is the y-intercept? Well, the y-intercept is when the graph hits the y-axis. It actually crosses the y-axis. We can see that there is one in this graph, right here. It touches the y-axis. We can find out the y-intercept when we have a rule. We can find the y-intercept by letting x equal 0. We also know from this table when x equals 0. We know here that this is x equals 0. So what does our y equal at this point? It equals 4. So we have already solved what c equals, which is plus 4. We would still need to find our m. We can find our x actually after finding our gradient by substituting values into this equation, and I'll show you how to do that. But we can actually look at the table here. We're lucky enough that this example gives us our y-intercept straight away. Let's find out our gradient. Okay, our gradient, we need to use 2 points on a graph. So we could use any 2 points. And our gradient is known, how you can actually find it out, is the rise over our run. It actually will give you a triangle. So it's the difference between 2 points. It's going to tell us, the gradient tells us the slope. It's going to tell us how steep this line is. That's what our m value is. So let me rub this out. So our m value, we know, is rise over run. How do we find the rise over run? Well, the rise is the change in the y values of the 2 points. What is our run? The change in our x values. So we can rewrite our equation to look like m equals y2 take y1 so the difference between the y points of these 2 points, over x2 take x1. y2 and y1 just represent the two y values between those points, and it will make more sense when we actually start using numbers, and that's the same with our x. So what we need to do first is we need to identify the 2 points we're going to work with. Well, this one here at the top is 313. Roughly it is 313. And this one down here is 1 and 7. When we have those 2 points, we need to label which one is our first point and which one is our second point, hence using x1, x2 and y1, x2. Y1, y2 I should say. So let's label the first point as x1, y1. Now let's label our second point as x2, y2. Now all we have to do to find the gradient is substitute these numbers into our equation. So m equals, what's our y2? 13. Take, what's our y1? 7. Over, what's our x2? 3. Take our x1, which is 1. Therefore, m equals, what does it equal? I'm going to move this over here. So I'll rub out our y-intercept. Okay, so m equals, what's 13 take 7? It's 6. What's 3 take 1? 2. Then we just have to do the division. What's 6 divided by 2? It's 3. So we know that our gradient equals 3. So what do we know in our rule now? We know that y equals 3x. What we want to know now, though, is what our y-intercept will be. Well, as I said previously, we can already tell from the table that when x equals 0, we get our y-intercept, which was 4. So all we have to do to complete our linear equation is say plus 4. And this is how you find the rule of a linear graph. If our y value was negative 4, in our rule it would be take 4. Thank you for listening.